This is a revision for the right angle triangles assessment, and from the practice assessment we're going to look at what you need to be able to do for achieve. So in the assessment you were given the ramp, okay, you were given the regulations for the angle, which meant that this needed to be 7 degrees, and the first thing you had to do was measure the vertical height of the stairs. So depending on the stairs, we went outside and measured this height here, which is 75 centimeters. And from there, you should be able to create a right angle triangle because you have this horizontal and you have this vertical, which means that this here must be 90 degrees. Since we have a 90 degrees right angle triangle, we can start using Pythagoras or trigonometry to be able to work out some lengths. So first of all, to make sure that you get one of the achieved skills, measuring your lengths accurately will give you achieved for measurement. We need to have 3 methods. Once we have that distance, we can look at finding both this bottom length and also actually the length of the ramp itself. So we want to find those 2 distances separately. I'm going to call the first one X and the second one Y. And you'll see I have 2 triangles here. That's because I want to use each one separately to try and find out those different lengths. It's also because I need to be able to demonstrate both use of trigonometry and Pythagoras to make sure I've covered all 3 methods for the assessment. So I'm going to start off using this triangle to find X. As you can see, we've got one distance and an angle. Anything that involves an angle means we need to use trigonometry and SOHCAHTOA. If we label the sides, we can see that we have the opposite side is the number that we're given, and the thing that we're trying to find out is this side X, which is in between the 90 and the angle, which means it's the adjacent side. We then look to see what part of SOHCAHTOA has the O and the A, and in this particular case, the O and the A is in TOA. Always draw the triangle, please, to make sure you get them in the right place, and the middle letter always goes on the top. Once you have that triangle, substitute into it. So T stands for tan the angle. So tan, please put the angle inside brackets. Opposite is the other length that we're given, so 75. The adjacent is the thing that we're trying to find out, which is X. X equals, cover it up. We see the 75 is above the tan 7, therefore it should be divided. 75 divided by tan 7. And when we put that into our calculator, we'll find that the answer will be 610.8 centimeters, 1 decimal place. Please remember to use a sensible rounding. So we've now demonstrated the measurement skill. We've also demonstrated the trigonometry skill. So for that we get inlaid with a little t. So that means we have 2 methods. It is possible to use trigonometry again to find this distance y. However, we want to be able to demonstrate that we are also able to use Pythagoras. As we just found this length x, when we make our triangle again, we use 75 as per before, but we use this distance that we just found. We don't need to worry about the angle because we're using Pythagoras, and Pythagoras doesn't use an angle. We have 2 lengths. We're looking for the long side. That means we add the squares of the 2 short sides. So this length y is going to equal the square of each of the two sides added together. We then take the square root of that, which will give us an answer of 615.4 centimetres. Once we have that, that is our A for P, and we've demonstrated that we're able to use Pythagoras.